Hello class, welcome to Pre-Algebra Lesson 11.3, which is all about angle relationships and parallel lines. By the end of this lesson, you should be able to examine relationships of angles formed by parallel lines cut by a transversal. So you might be thinking, I just said a lot of words that maybe sound familiar and you don't remember what they mean, or maybe some words that you think, I've never heard of that before. And that's okay. So this whole lesson is gonna feel like you're just learning a bunch of new words, really. It's gonna feel like more like a vocabulary lesson than an actual like math lesson with numbers and stuff, okay? So make sure you take good notes during this lesson because it can be really tricky to remember all of these different angle relationships. And if you want, maybe even make note cards or like flashcards for each angle relationship we talk about during the video, so that way you can study off of your flashcards. Okay, just some ideas. Okay, so I hope you're ready to learn a bunch of new words. All right, let's start with some things that might seem familiar. So if we're looking at this top picture here, we're going to look at the fact that there's this little kind of pink box right here. And what this pink box means is that these lines are forming a right angle. And a right angle is 90 degrees. Another word we use to indicate 90 degrees is the word perpendicular. Okay, so perpendicular means 90 degrees. Okay, and this symbol also means 90 degrees. Now, you might see things like this, and the way this is read is lines L and M are perpendicular. So you can see this line right here is called L, that's a cursive L, and then this line here is M, and so lines L and M are perpendicular. They form that 90 degrees. Instead of having to write out this big long sentence, a faster way to write it is using symbols, where you just take the name of the line, you do an upside down T to represent perpendicular, and then you do the second line name, okay? So that's perpendicular. Now let's talk about parallel. Remember, parallel means that two lines never touch. Okay, so here we have lines S and line T. So here's line S, here's line T. They're never going to touch, they're parallel. And the way that we symbolize that on a graph is use these little arrows drawn partway on the line. Okay, so arrowheads are used to indicate parallel lines. And then instead of having to write lines S and T are parallel, a faster way to write it is to write the names of the lines and then in between do two vertical lines. So that says lines S and T are parallel. Okay? And then here you can see that we have another word. This new word that probably you probably haven't heard of before is transversal. So what a transversal is any line that cuts through other lines. So like here we have two parallel lines and then we have this line cutting through it that is known as the transversal. Okay, so that was our first page of vocab. Now for our second page of vocab. We are going to talk about something called interior angles. So let's pause for a minute and just think about what we know about the word interior. Usually, I would say the most common use of interior that you might hear is something like interior designer or something like that. Interior designer is someone that designs the inside of a house, okay? So interior means inside, okay? So interior angles are the angles that are inside or between two parallel lines. So here we have two parallel lines, and then these are our interior angles. Angles 4, 3, 5, and 6. They're all between or inside those two parallel lines, right? Like if I were to shade the area between my parallel lines, that would highlight angles 3, 4, 5, 6. Okay, now let's talk exterior. Exterior means outside, okay? So that's a good thing to maybe make note of for yourself. So outside means anything not between the parallel lines. So in this case, it'd be angles 1, 2, 7, and 8. Those are all angles that are outside of our parallel lines. Okay, so you need to make sure you know all of these vocab words. So the first one we learned on the last page was perpendicular. then we talked parallel, then we talked transversal. Now we're talking interior or inside angles and exterior or outside angles. Okay, now we're going to learn even more vocabulary, more specific. Okay, so now, look, we're talking about interior angles still. So we're talking about the ones that are inside, in between those two parallel lines. Okay, so inside those two parallel lines, we already said we had angles 3, 4, 5, and 6. Now what alternate means every other. Okay, so in this case, if we look at 3, 4, 5, 6, the every other that we're talking about is that you have one on each side of the transversal. Okay, so line L right here is our transversal. And if I start with angle 3, which is an interior angle, the angle that would be alternate to it would be angle 5, because it's still on the interior, it's still between our parallel lines, but it's just flipped to the other side of the line. Okay, and alternate interior angles don't touch. Okay, so you wouldn't say that 3 and 4 are alternate interior angles. Those are just supplementary. We talked about that last lesson. Okay, so alternate interior would be like this right here, 3 and 5. Or another example would be 6 and 4 are also interior angles and on opposite sides of the transversal that don't touch each other. Okay, and one thing to know that alternate interior angles, they are equal. Okay, so if angle 4 is 105, angle 6 is 105. Okay, if angle 3 is 75, angle 5 is 75. Okay, so that's something that can be a nice shortcut in helping you solve like for what angle measures are. Okay, so we've talked alternate interior. Now let's talk alternate exterior. So again, alternate still means opposite sides of the transversal. And if we look, angle 1 would be an alternate exterior with angle 7 because they're both on the outside of our parallel lines, right? They're not inside, they're outside. And then they are on opposite sides of that transversal, but they're also not touching each other. They're not next to each other because angle 1 and angle 2 would just be supplementary. Angle 7 and angle 8 would just be supplementary. But 1 and 7, alternate exterior. And then we have 2 and 8 are alternate exterior as well. So that would mean that if angle 2 is 120, angle 8 is 120. If angle 7 is 60, then angle 1 is 60. Okay? So those are our alternate exterior angles, and they are also equal. All right, then let's talk about corresponding angles. All right, so corresponding angles are angles that are in the same position on the two lines. Okay, so if we look at angle 1, okay, so I'm going to highlight it green here. This is angle 1. If I were to take that angle and just slide it this way, do you see how it would just become, it would be the same thing as angle 5? That's an example of a corresponding angle. Okay, so corresponding angles end up being on the same side of the transversal. So like angle 1 and angle 5 are both on the left side of the transversal. And then if you look at your parallel lines, here's my parallel line. Angle 1 is above my parallel line, and angle 5 is above my parallel line. So you can see that these are corresponding angles. Just like if we were to look at angle 2, or actually, let's look at angle 3. So angle 3 is on the right side of my transversal, and then it is below this top parallel line. So if I go to my other parallel line, I'm looking for something that's below, but also to the left of my transversal. That means 3 and 7 are corresponding angles. And something to know about corresponding angles is that they are also equal. Okay, so all of these angle measures we've talked about so far today are equal to each other. Okay, that's different than when we talked about complementary and supplementary. All right, so now we are going to practice classifying angle pairs. So we want to classify whether it's alternate interior, alternate exterior, or corresponding. So I have angle 1 and angle 7. So I notice right away they're on the outside of my parallel lines, so I know they're exterior. So I know that it can't be alternate interior. So then alternate exterior means they're on opposite sides of the transversal. So I would have one on the left, one on the right. In this case, I have one on the left and I have one on the right. So I know that these are alternate exterior. If they were corresponding, I'd be looking for two angles that are on the same side of the transversal. Okay, so hopefully that makes sense. All right, so now I want you to classify this relationship as either alternate interior, alternate exterior, or corresponding. Good luck. Okay, so hopefully you said angle 4 and angle 6 are both between the parallel lines. That means that they have to be interior. And so if they're interior, I know that they can't be the alternate exterior. And I have one on each side of my transversal, one on each side of this line. I know that it must be alternate, which means that my answer would be alternate interior. Okay. So let's practice another one. If I look at angle 2 and angle 6, you can see that I have two angles. You can see that one's on the outside, one's on the inside. And when you have one on the outside, one on the inside, that can be a good indicator that you have corresponding angles. Okay, so right there, I know that I have corresponding. Okay, so for alternate interior, both have to be interior. For alternate exterior, both have to be exterior. For corresponding, you get one of each. Okay, so that can be sometimes an easier way to identify those corresponding angles. All right, here's another example for you to try on your own. Go ahead and classify the relationship as alternate interior, alternate exterior, or corresponding. Good luck. All right, so for this example, hopefully you said, okay, angle 2 and angle 8. I noticed that those are both on the outside of my parallel lines. That means that it has to be alternate exterior. Okay. So now, knowing what we know, we want to be able to find the measure of each angle listed below. Okay, so let's start with, we know angle 1 is 50 degrees. So then, if I move on to angle 2, how are angle 1 and angle 2 related? Well, from our last lesson, I learned that when they form a straight line, they are supplementary. And supplementary means that they add up to 180 degrees. So I would say 180 minus 50, because that's what angle 1 equals. I would find that the measure of angle 2 is 130 degrees. So I would write 130. Okay. And then going from there, angle 3, if I think about it, again, pulling from, I think it was 2 lessons ago now, we learned about something called vertical angles, where when you have something that forms an X, the angles on opposite sides of the X are equal. So angle 1 and angle 3 would be the same. So since angle 1 is 50, angle 3 is also 50. And then angle 4, again, is a vertical angle with angle 2, so I know that this would also be 130 degrees. Okay, so hopefully that doesn't seem too bad. Now let's move on to, okay, so we did the top portion of that picture. Now let's move on to the bottom portion. So if I look at angle 5, I have a couple of different ways that I can figure out what angle 5 is. I can either say, hey, angle 5 is an alternate interior angle, like with angle 3, which means that they are the same. So this would be 50. I could also say that angle 5 is a corresponding angle with angle 1, also making this 50. So I know that angle 5 is 50. Okay, so then if this is 50, then I know that angle 6, I can look at angle 6 would be an alternate interior with angle 4, or angle 6 would be corresponding with angle 2, meaning that angle 6 is also 130 degrees. And by now, you might be noticing a pattern of these, say 50, 130, 130, 50. This now says 50, 130. So we can assume that angle 7 would be 130 and then 50. And the way that we could get angle 7 is we could either say it's corresponding with angle 4, we could say it's an alternate exterior with angle 2, or we could say it's vertical with angle 6. So I know that it is 130 degrees. And the same for angle 8. I could say angle 8 is vertical with angle 5, or I could say angle 8 is corresponding with angle 3, or I could say angle 8 is an alternate exterior with angle 1, therefore making angle 8 50 degrees. Okay, so using those angle relationships, if you memorize them, these things can go pretty quickly, but I also know that it can be kind of tricky to memorize so many things at once, that it can be frustrating. So please, if you have questions, stop the video, ask for help, or when you're doing your homework, if you're getting frustrated, stop and ask for help. I'm happy to help you. It's why I signed up to be a teacher. I like to help you learn, okay? But you have to be willing to ask questions. All right, now let's practice with a picture that looks a little different. So we have Mrs. Kumar designed the bookcase shown, and we know that line A is parallel to line B. Okay, so those two shelves are parallel. Now, if we know that the measure of angle 2 is 105 degrees, we want to figure out what's the measure of angle 6 and the measure of angle 3. So, if I look, 105, that's my angle 2. How is that related to that angle 6? Well, drawing on yesterday's lesson, that forms a straight line. Those two angles form a straight line, which means they are supplementary. And supplementary means 180 degrees. So if I say 180 degrees minus 105, I would figure out angle 6. So 180 minus 105 is 75. So now I know that the measure of angle 6 equals 75. And then, looking at angle 3, I know that angle 3 is an alternate interior with angle 6. So I also know that the measure of angle 3 is 75. And I'm done. Okay, so knowing those angle relationships means that I don't have to do a second calculation. I just know that those are both going to be 75. Okay. So now I want you to find the missing angle measure. So we know that two parallel streets are intersected by another street as shown. We know that angle 2 is 53. So the measure of angle 2 is 53. Okay, so that's right there. And I want to figure out what 7 and what 8 are. So I want you to solve this one on your own. I would recommend starting with angle 8, and I'll explain why in a little bit, but maybe you can figure it out on your own. Either way, good luck. Okay, for this problem, hopefully you figured out that since angle 2 is 53 degrees, that means that angle 8 is also 53 degrees because they are alternate exterior angles. But then, angle 2 and angle 7 aren't related. They're not corresponding, even though they're both on the same side of the transversal. They're both outside. They're both exterior angles, so they're not corresponding. So what you have to do is look for another angle relationship. So I looked and I saw, hey, angle 7 and angle 8 form this straight line, and straight lines are supplementary, which means they add up to 180. So I said 180 minus 53 gives me 127. So I know that the measure of angle 7 is 127. If you have questions about that, please be sure to ask for some help. I'm happy to help you. And let's move on to our last example for today. So in the figure, line M is parallel to line N, and line Q is perpendicular to line P. The measure of angle 1 is 40 degrees. What is the measure of angle 7? Okay, so this picture might look really overwhelming to you. You might be thinking, Ms. Johnson, I see two parallel lines, but then I also see two perpendicular lines, and they're all intersecting, and that's overwhelming. And you're right, that can be tricky. That can feel overwhelming. But take a breath, And let's break this picture down. Okay, so let's start with the stuff we know. The measure of angle 1 is 40 degrees. Okay, so if I know that the measure of angle 1 is 40 degrees, what are some other things I can figure out? I can figure out that, okay, angle 2 forms a straight line with it, so that's supplementary. So if I do 180 minus 40, I get 140. So I know that the measure of angle 2 is 140 degrees. And this angle right here is a vertical angle with angle 10, so this is also 140 degrees. And this angle right here, angle 1, was vertical with angle 9, so this is 40 degrees. I know that this right angle here means that this is 90. And then I can say, okay, what is angle 3 related to? Well, angle 3 is related to angle 1. Those are corresponding angles. So those are both 40. All right, and then there, I could keep going. I could keep solving things and say, okay, if this is 90, this is 90. If this is 40, this is 40. But then I still have these two angles to solve for. So how do I do that? Well, looking at this picture, I see a straight line. And I see that this straight line is actually made up of 3 angles. So instead I can do 180 minus 90 minus 40 equals angle 7. Because those 3 angles added together form that straight line. So 180 minus 90 is just 90. 90 minus 40 is 50. So I know that the measure of angle 7 is 50. So angle 7 equals 50 degrees. So that's one way that you could break down this picture. Another way that you could do it that would be a little faster, if you feel like you can identify these angle relationships, you can try to do it a little quicker. And the way you can do that is, you know, angle 1 is 40. And then angle 7 is all the way down here. So I want to, I don't really care about angles 9, 2, and 10. They aren't close to angle 7. So what I can do instead is say, hey, this is 40 degrees. That's corresponding with angle 3. That's 40 degrees. I know that this symbol right here represents 90 degrees. And then see right from there that you have 3 angles that add up to 180. And then you would get straight to here. Okay, so if you can pick up on those relationships faster, it can help you solve things in a shorter amount of time. If you can't, you can go a longer way and still get the right answer. Okay, so just be sure to take a breath, break down the picture, write what you know, and work your way towards that angle you're solving for. Okay, if you have questions about that, please be sure to ask for some help. Otherwise, here's a question for you to solve on your own. We have in the figure, line A is parallel to line B, and line C is perpendicular to line D. The measure of angle 7 is 125 degrees, and we want to solve for the measure of angle 4. Good luck. All right, for this problem, hopefully you ended up with the angle 4 equals 35 degrees. And the way you got there was maybe going from angle 7 and angle 10 are supplementary. So since angle 7 is 125, angle 10 is 55 degrees. And then I saw that angle 10 and angle 3 are related because they're alternate interior. And then I used angles 2, 3, and 4, knowing that those were supplementary. And I knew what angle 2 was because it's vertical with angle 5, which was 90. And then I did supplementary, so 180 minus 90 minus 55 gave me 35 degrees for angle 4. Okay, so if you have questions about that problem, please be sure to reach out for some help. I am happy to help you. Otherwise, have a great day.